Students, myself Archana Varude from Praveen Patel College of Diploma Engineering and Technology. In last video, we have already studied about statement of Stokes law, and after watching this video, you will be able to understand how to find the coefficient of viscosity by Stokes method, what is meant by upthrust force and what is meant by force of viscosity. For that, first we take revision of Stokes law. Statement of Stokes law is the force of viscosity experienced by a small metal sphere falling freely through a viscous medium with terminal velocity is directly proportional to the radius of metal sphere. It is also directly proportional to the terminal velocity, and it is also directly proportional to the viscosity of liquid. And therefore from that we write the equation F, that means viscous force, is directly proportional to eta, that is coefficient of viscosity. R means terminal radius of metal sphere and V means terminal velocity, and therefore we get the equation F is directly proportional to eta RV. And if we take equal sign in next step, then consider a constant on right hand side, and in this equation that constant is 6 pi, and therefore equation is F equals to 6 pi eta RV. And here to find the coefficient of viscosity by Stokes method, consider a glass jar, tall glass jar, in which metal sphere is dropped very carefully in this middle size, and then as we know that after covering certain distance, that ball bearing falls with a constant velocity is known as terminal velocity, and when this ball bearing comes in downward direction, then at the same timing there are two forces are acting in upward direction, and that two forces are called as force of viscosity and upthrust force. Here, and when that metal sphere goes in downward direction, then there is a force called as downward force, and it is equals to weight of the metal sphere in downward direction. Then second is force of viscosity in the upward direction, and third is upthrust force. It is also known as force of buoyancy, and it is in the upward direction. And therefore from that we clear that there is only one downward force, and it is equals to the weight of metal sphere, but there are two upward forces are acting on ball bearing. First is force of viscosity, and second is upthrust force, or it is known as force of buoyancy. And here we find that values of force of viscosity in upward direction, and also that value of upthrust force in upward direction. And practically it is observed that if weight of person is 65 kg in air, then it may be 45 kg in liquid, and the reason is that because liquid tries to lift the body and create upward force, and that force is called as buoyant force, or it is also known as upthrust force, and it is the force with which liquid lifts the body deep into it. That means it opposes that body, and therefore by Archimedes principle we write upthrust force is equals to loss of weight of body in liquid, and according to the Archimedes principle that loss of weight of object is equals to the weight of displaced liquid. And here since metal sphere falls with constant velocity called as terminal velocity, and therefore the total upward force is equal to the total downward force, and therefore here we write total upward force is equals to total downward force. But here there are two forces are acting in upward direction, and therefore total upward force is equals to force of viscosity plus upthrust force, and it is equals to total downward force, and it is equals to the weight of metal sphere. And according to the Stokes law, force of viscosity is equals to 6 pi eta RV plus upthrust force is equals to weight of displaced liquid. It is due to Archimedes principle, and it is equals to weight of metal sphere. Then again in next step 6 pi eta RV as it is plus weight of displaced liquid. We know the formula W equals to m into G, and therefore we write mass of displaced liquid into gravity. It is equals to then weight of metal sphere is equals to mass of metal sphere into gravitational force. Therefore, we get 6 pi eta RV plus, here we have to find the mass of displaced liquid, and we know the formula for density is mass upon volume, and therefore here we get mass of displaced liquid is equals to volume of displaced liquid into density of liquid, and here G as it is. Then again mass of metal sphere is equals to volume of metal sphere into density of metal, and gravitational force as it is. Then we write the formula as 6 pi eta RV plus volume of displaced liquid. When we consider density of liquid is rho, then it is rho and this G as it is, but volume of displaced liquid is given by the formula 4 upon 3 pi r cube, where r is radius of that glass tube. Then it is equals to, again density of metal is considered as D, and gravitational force is same, and volume of metal sphere is given by 4 by 3 pi r cube. Then here this 4 by 3 pi r cube, it is common, therefore here this 4 by 3 pi r cube rho into G, it is taken on right hand side, therefore we get the equation 6 pi eta RV is equals to, in bracket 4 upon 3 pi r cube dg minus 4 upon 3 pi r cube rho into G. Here 4 by 3 upon pi r cube is common, we take outside the bracket, therefore equation is 6 pi eta RV is equals to 4 upon 3 pi r cube, G is also common, in bracket D minus rho, where D is density of metal sphere minus rho is density of liquid. Then here we take that 6 pi RV on right hand side, therefore equation is eta equals to 4 by 3 pi r cube G in bracket D minus rho upon 6 pi RV. Then the last formula is, we get eta equals to 2r square into G in bracket D minus rho upon 9V, and where eta is called as coefficient of viscosity of liquid, r is radius of metal sphere, D is density of metal, rho is density of liquid, and V is terminal velocity, and this formula is called as a coefficient of viscosity by Stokes method. See this diagram, in this diagram we write the formula for, that is weight of metal sphere, then force of viscosity, and second is that upthrust force, and these equations are used in these last PPTs. See here. Then now we solve MCQs. First is upthrust force is also known as, option A is force of buoyancy, option B is force of viscosity, option C is downward force, option D is viscous force. And as we know that upthrust force is also known as buoyant force, or it is also known as force of buoyancy. Therefore correct option is A, force of buoyancy. Then question number 2 is, how many forces are experienced by a metal sphere when it falling freely through a liquid column? And as we see in this earlier slide, that when that ball bearing falling in a liquid column, then there are three forces are acting on that metal sphere, and therefore here correct option is B, 3. Question number 3 is Stokes equation is given by. Option A is F equals to 6 pi upon eta RV. Option B is F equals to 6 pi eta RV. Option C is F equals to 6 pi eta RV upon V. And option D is none of these. And as we see in first slide that Stokes equation is given by F equals to 6 pi eta RV. And therefore correct option is B, F equals to 6 pi eta RV. And question number 4 is Stokes equation V is called as. Option A is terminal velocity, option B is critical velocity, option C is coefficient of viscosity, and option D is radius. And as we know that in Stokes equation that V is called as terminal velocity, and it is a constant velocity with which that ball bearing falls through a liquid column. That's all about today's video. Thank you.